Good afternoon or morning, depending on where you are, and welcome to this week's episode of Improving Talks. Before we begin, I'd like to draw your attention to the Q&A button at the bottom of your Zoom client. If you have any questions, please use that to post your questions, and they will be answered during the course of the presentation. The speaker for today is Andy Hainson. Andy is the Director of Technology for Platform Engineering Practice in Improving's Minnesota office. Andy has been with Improving for 8.5 years. The topic for today is continuous innovation, building enterprise-scale platforms for public cloud adoption. Without further ado, here is Andy Hainson.
Thank you, Michael. Yeah, so as Michael mentioned, I'm Andy Hainson. I'm happy to bring this to Improving Talks today. Kind of wrapping out the rest of our month of June, where we focus on platform engineering. Very great talks so far this month. So today I wanted to talk a little bit more about sort of wrapping all of the different topics together and talking about what it takes to actually build a platform that enables enterprises to adopt the cloud. So I guess to start off, we'll just jump right in and say, what is platform engineering? Why are we using this term? This is something that has kind of come out of the evolution of organizations trying to adopt a DevOps mindset. What we saw is, more and more tools being involved, different workflows and processes. We're trying to enable development teams to, own their infrastructure, own their application deployments, own their CI/CD processes. But as that has sort of scaled and sprawled across organizations, there's been this shift in maturing that practice into a centralized team that is there to provide a platform, sort of unifying the rest of those different siloed groups across an organization. So a platform team, a platform engineering team, is there to really centralize the infrastructure that supports the rest of the organization's application development, delivering products, providing services. There's a strong emphasis on utilizing automation and self-service, and we're really using platform engineering as a place to provide guardrails to empower that DevOps workflow, abstract away some of the complexity, and unify on tooling and the rest of the decision-making around compliance and security. You're going to hear me say compliance and security and compliance many times throughout this talk. As myself, I've worked within a lot of highly regulated environments, such as healthcare, financial institutions, and part of adopting the cloud and part of building out a platform is really there to provide consistency, compliance, and security. So we'll jump right in and start talking about what I see are some of the key components to developing this practice. So I would say that this is not necessarily a comprehensive, what does a platform team need to be responsible for, but these are the key components that I think we need to focus on when building out a platform for the rest of an organization, especially a platform that's going to scale over time for the rest of the organization. So we're going to start with planning and governance, often called the Cloud Center of Excellence, CCOE. And this is a governing body, a group of individuals that's there to help strategize, architect, drive cloud adoption within an organization. The second sort of key component is really important to me personally as a platform engineer, and that's infrastructure as code. We're there to accelerate adoption, increase productivity, and provide value to the rest of the organization in a secure and compliant way. There's associated risk with moving workloads and data to a public cloud provider, but using infrastructure as code, we can mitigate some of that by enforcing policy and making sure that we have a consistent way of doing things across our organization. The next key component here tacks onto the infrastructure as code, and that's continuous integration, continuous deployment. So CI/CD as it relates to the platform and the infrastructure, we're here to use that as part of the platform the same way that an application team might use CI/CD as part of their software delivery lifecycle. We're there to make sure that we're iterating, that we're building, that we're fixing and plugging holes where we can, and maintaining, again, that security and compliance. And then as we mature out of these sort of the first three, we're starting to look into self-service provisioning of infrastructure and resources within the cloud and integrating that into the rest of the organization's existing tooling, existing processes, and making sure that this platform is there to serve as many people as we can within the organization. I'm going to try to keep this presentation sort of conversational. So as Michael said, feel free to throw questions in the Q&A. I'm happy to stop and answer questions as we go. If anything is on your mind, please do post it there. So talking about this CCOE, the Cloud Center of Excellence, we're trying to figure out, at the very beginning of a cloud journey, and maybe you've already stepped into the cloud and you're already starting to deploy workloads. This is really a maturity step to make sure that you're able to adopt this in a way that makes sense for the whole organization and that it is going to scale in the future. This group is there to sort of, collaborate, figure out what we're doing. So the first step is really just getting the stakeholders together. Many organizations today are still very siloed into an IT structure where they have separate teams dedicated maybe to network or infrastructure or security. And those teams are not always on the same page. They probably work together, but there's sort of these siloed environments of technical experts. And we want to gather as many people as we can into this group to keep everybody on the same page as we move forward with adopting cloud. So this is a cross-functional team. The IT leaders, there's going to be business executives, business analysts, product management type folks, really there to provide, here's the objectives and here's the business value and what we're trying to get out of this project. There's going to need to be financial professionals involved. There's sort of a myth around the cloud sometimes that moving to the cloud means that things are going to be less expensive than provisioning hardware on-prem. And that's not always the case. It can be the case. We'll touch on some good reasons to move to the cloud, but we want to include those folks because we want to make sure that this cost is not spiraling out of control by adopting new services here and there and being accountable for where our dollars are going as we adopt cloud services. And then sort of finally, legal and compliance professionals. So this is usually two different groups of people, but keeping legal in the loop of any sort of contractual obligations we have around our data, where it lives, where it's moving. And then compliance is usually more of a security-focused team, focusing on policy, making sure that we are enforcing different encryption standards and firewalls and all of those sorts of things. So once we've got this group together, the idea is that we will meet regularly and start to architect and collaborate on what this cloud strategy looks like. The whole reason for gathering this group of individuals is to leverage their expertise, figure out which teams have insights into different products or applications or use cases. We want to sort of identify upfront what are the policies, what is the architecture, what is our strategy for bringing on a new team or a new product, when do we use the cloud and where can we leverage it, are we able to do that? We're here to establish a roadmap for the rest of the organization that says we're moving workloads to the cloud. Let's make sure we're doing so in a safe and efficient way. Which leads into the last part here of continuous improvement. This is an ongoing place for folks to collaborate. We're there to make sure that we're reviewing the progress of what we've done within our cloud journey, and make sure that we can address any challenges that might have come up, keeping everybody on the same page, making sure that we're able to adapt and plan to keep pace with different business requirements, or maybe even technology or service enhancements that have come along, new services or new frameworks of doing work. We want to make sure that this group is meeting regularly and able to make sure that that roadmap is adapting and staying ahead of the curve, really. And again, this is all about collaboration and communication. Far too often there are siloed groups within an org, and we want to reduce that effort. So as we look into what that means from the benefits of keeping the CCOE going, is really that efficiency and centralizing our cloud related activities. We're trying to reduce the duplication of effort and ensure that our resources, both time, people, money, are being used effectively. And having all of this centralized really helps bring that to a fruition of making sure that everybody's on the same page. We know what we're doing. We know where we're going. We know what's next. We're ready to plan. And that's really the benefit of having this as sort of your starting step. I again, touching on the security and compliance piece of this, having that CCOE and that open communication channel that you're constantly iterating on is really there. It's helping enforce security guidelines and best practices. And really, in my experience, deciding on some of that security and compliance work up front just means that the start of the project where your teams are actually implementing this cloud adoption, implementing and adopting cloud services, we're upfront with the security policy that's hard-coded into our environments. It's making sure that we're going to improve the approval process when it comes to time to start moving workloads to the cloud, and we're going to be able to make sure that we're doing things the right way from the start. Also centralizing this and keeping those business and product folks and application teams involved really helps other business units understand the capabilities and also the limitations of cloud solutions. So this is a venue where we can make informed decisions quickly without the need for additional meetings of deciding something that might be either financially or technically not feasible. So making sure that we are leaning on that expertise again and having that open forum. One of the biggest advantages to moving to the cloud is being able to take advantage of the opportunity for innovation. By paying for what you use and when you need it, we're really empowering organizations to experiment and explore new technologies without needing to procure extra hardware on-prem, install new servers, waiting around for provisioning. We're able to do that in near real time and allow development teams to innovate more quickly. We're also able to take advantage of a lot of hosted services. So I've got sort of the big three public cloud providers on this slide, and each of them offer different services around containerization with hosted Kubernetes platforms, hosted event streaming platforms. These are there so that we can take some of the burden and complexity off of the development teams, even off of the platform teams, and we are no longer administrating all of those different services. We're able to take advantage of a reliable platform that gives us access to these tools and technologies really quickly without needing to build all of that knowledge internally. So I will pause there for just a moment and say, the Cloud Center of Excellence is sort of our pillar and it's our starting point. This is often going to happen or should happen, in my opinion, even before we start moving workloads to the cloud. And again, maybe you've already started to sort of adopt cloud resources or workflows within an organization, but it might be within one development team or one application. But the CCOE is there to provide a scalable group of people across the entire organization. Moving on from the CCOE, this one is the piece that's, like I said, most important to me as an application or a platform engineer, and that's infrastructure as code. So the idea behind infrastructure as code is we are trying to treat all of our infrastructure, all of our cloud resources the same way that we would application code. So we are using a declarative way of defining what our environments should look like, what our infrastructure should look like from a networking perspective, from a sizing and resourcing perspective. And we're doing it in a way that we can follow best practices that we would for any other application. One of the great things that comes out of this is we now have a hard-coded way to enforce policy when it comes to security and compliance. We're enforcing that through code. We no longer have somebody maybe going out into a cloud portal somewhere and clicking around in the screens and changing settings, opening up firewalls, any of that, because we're now limiting access to infrastructure as code to make those changes for us. This sort of falls into the last section on this slide here and talking about centralized reusable artifacts. And so really the point of that there is to say that regardless of what infrastructure as code tool you use, we want to have a way to make this repeatable, make this consumable, and what will play into, as we get further along here, into like self-service and being able to mature and scale the infrastructure as code footprint. So if you're using something like Azure ARM templates or maybe AWS CloudFormation templates, we want to have a centralized place to distribute those so that application teams, again, we're trying to abstract away some of the complexity of using the cloud and providing a way for them to have consumable resources that are no longer, based just on them going out and learning the cloud, trying to figure out all of the different bits and pieces, all of the knobs that they might need to turn. We're making sure that, again, those reusable artifacts are compliant. They've already gotten a stamp of approval from security, and we're able to also version these. So keeping the idea of our infrastructure is code, we want to treat it just like an application. So we can promote changes throughout our environments, following our version control strategies around tagging and making sure that we know what is running where, all of the observability that comes with that. Doing things through code also just provides an audit trail. We know who's changing what infrastructure and when, and we can put different workflows around that for approvals and making sure that we know when something is changing, why something is changing, all of that. That's the compliance side of that enforcement. So it wouldn't be code development without our third sort of pillar here of talking about continuous integration and continuous deployment. So the role that this is playing is just like an application team. We're here to make sure that we are doing rapid deployments, making sure that we can quickly make changes. Specifically when we're talking about infrastructure as code as it relates to CI/CD, this is really an opportunity to take advantage of those tools. I'm partial to HashiCorp's Terraform when it comes to my infrastructure as code tool of choice. And one of the great parts of Terraform is just drift detection. So let's say that somebody does have the ability to go change something in the portal. because they have some sort of elevated permissions. Continuous integration, our CI/CD processes are going to detect the drift from what exists in the real world out in the cloud and what exists in our declared definition of our infrastructure. And we're able to sort of automatically remediate that. There's some maturity around the automated remediation piece of that, where there's lots of different tools that allow you to do this in sort of real time, where a pipeline or Terraform is only going to know about these changes each time you run it. But there's different strategies for how you scale this and make sure that you're in a compliant state and you're safeguarding the integrity of your different cloud environments. This middle column here of CI/CD is, we're dramatically reducing time and effort for developers to deliver these cloud-based applications and services. They're able to focus on what they're delivering to the business or their application rather than repetitive tasks or manual intervention from their workstation. They're able to take advantage of pipelining tools, whether that's GitHub Actions, Azure DevOps, GitLab pipelines, maybe you're running Jenkins somewhere. But developers are able to take advantage of the infrastructure as code repository, that centralized repository of artifacts, and reduce their need to know what complexity went into that. And then finally, just like with our application code, the CI/CD process gives us rapid and iterative deployments of being able to adjust to changing needs or changing demands. We might have suddenly a service that needs to talk across to another different backend in another environment, or in another application team's account. And we're able to quickly, through code, follow a process that we can make the change. We have a track of who made the change, and we're able to quickly deploy that and promote it through the environments. So just like you would patch a bug or something in your application and be able to quickly test that through an automated process into a development environment, we're able to do the same thing with our infrastructure now, of making sure that we know where things are at and we're able to promote changes quickly throughout the environment. So that agility, again, is part of the key benefit in using the public cloud, being able to change or scale resources as needed, whether it's from a hardware limitation of we need more CPU power, we need more memory for this application, or it could be as simple as like cost optimization of scaling resources up and down to save costs during off-peak hours or things like that. So again, this all hinges on our version control system and being able to integrate that into the rest of our workflow when it comes to using the public cloud. So I don't want to spend too much time, but I did want to quickly show some of the power of this with a quick demo, just something that I put together so that we could talk about what this looks like in practice. Again, by no means is this exhaustive of what an enterprise scale platform would look like, but I'd like to just show quickly, how this all ties together. I think seeing it in action is a little bit easier way to consume the information. So last week, actually, John gave a great talk about infrastructure as code with a much deeper dive on what this looks like and some of the benefits and reasons that you should be looking at keeping this as part of your cloud adoption, your cloud strategy. So I won't go too far into the details of how Terraform works, but I wanted to show some of the real world example of what this looks like from a consumer's endpoint of maybe an application team. So you'll see here in my GitLab instance here, I've got a group that is called Central Source. And this is a pattern we've used with quite a few different clients where regardless of what version control system you're using, you have a centralized place for those artifacts. So in this case, I've got an AWS VPC module here that is going to make sure I can set up a private network that I control all of the knobs and dials and everything else that I have from AWS provided to me. And then I've got sort of a jump box server here that I will be deploying into that environment. So these are those central artifacts that I talked about with our infrastructure as code tooling, of saying that these have policy and compliance baked in. Um, a good workflow is to say that anything that gets changed in one of these centralized artifacts goes through a security review, so that as an application team, you know, if you are trying to launch a new database instance, if you're using our modules from our central source, you can think of it sort of like open source for an organization. You know that it's already passed security approval, and you're not going to get flagged on something of leaving a certain port open, or there's different IPs that can reach it, that sort of thing. So these are those centralized version artifacts that give us the power to like eventually get to self-service, and also just abstracting away complexity from the user. So I've got this repo here that is sort of like what you would see either from a platform team managing resources for a development team, or maybe it would be a development team themselves managing their own resources. And we can sort of ignore some of the boilerplate Terraform here, but what I really wanted to show was, you know, this is what it looks like to consume and provision resources via infrastructure as code. You know, we've got some definitions of some required variables here that our module is going to require to actually build out our VPC. But I think the biggest point that, you know, shows the power of this is even just saying that there's a jump box in this environment. You know, really all I needed to tell this module was what network to place this in and what subnet within that network that I should be placing this in. And again, this is just, you know, abstracting away and hard coding some same defaults into the applications, or into the modules rather. So once this has been pushed out to our version control, our pipeline system picks this up, and, you know, we have in Terraform the ability to deliver a plan of what's going to happen within this environment when we start to run this code. So in Terraform, it's going to figure out all of the state of the environment that is out on AWS in this case, and compare it to the state of our infrastructure. So we're trying to figure out, like, Terraform is going to figure out what it needs to perform to make those two things match and make them consistent. So as we scroll through here, you'll see there's a bunch of different policy, different resources of like IAM roles, different service accounts and things that will be created, different policies around what this jump box has access to, what it can do. And this is all baked in to that module, where I really only had to provide 2 different lines of code of where I wanted this to run. And the rest of this is baked into that reusable artifact. So this is what empowers, you know, building out those guardrails and making sure that we have, you know, scalable, like consumable resources for development teams. This whole section could have even been sort of a checkbox as we get into talking about, you know, self-service. It could be as simple as saying like, hey, I'm a new development team, we need a new environment, and I'm going to need a jump box to get into the private network. That could be a checkbox, and all of these resources could be created on their behalf without even needing to know what it really is, besides saying like, yes, I'm going to need external access to this environment. So going back to the pipeline here, we can see we have sort of this plan stage that's showing us all of our changes, and then an apply stage that was manually provisioned so that we get that that infrastructure created for us out in the environment. This also reduces like following best practices around like, you know, least privilege access. As a developer, I can make changes to the infrastructure as code but I don't need to provide that individual developer with access to the environment where they could update things directly. We're providing a way to do it through automation so that our credentials are secure, nobody's accidentally posting them or committing them. They don't even need permissions necessarily to be in the environment. They just need to be able to control their infrastructure and see it come out in the plan. So as we look at this again, I wanted to, briefly touch on, the idea of being able to iterate across these things. And let's say that this jump box server was not necessarily just a jump box, but maybe this is a virtual machine hosting an application of some sort. I was able to go in and update the code and say, the resources are too constrained. Right now it's running on an instance class that's too small. There's not enough CPU or memory. And without having to update a whole lot, I can override my default of my T2 micro and say, we're going to use the next generation EC2 instance and we need to bump it up to a small. The power of this is, we now have a merge request in this case. Maybe it would be a pull request on GitHub. But we're able to follow the same lifecycle that we would with an application. So we can say, we should be testing this for syntax, making sure that the Terraform code that was written actually passes sort of a linting test. The newer versions of Terraform that have come out in the last 6 months also have built-in testing. So we're following that same pattern of test, build before we actually merge our changes, making sure that the jobs that we're pushing, or the changes that we're pushing, do what we think they do. And then again, we get sort of this plan of like, here's what Terraform thinks needs to change in this instance. They're showing us here that we're going to go from a T2 micro instance to a T3 small. So it's matching what we expect. So upon merge, we know what's going to happen. We're declaring what our infrastructure is going to look like. Another, sort of interesting piece of this plan shows the drift that may have happened. Sometimes this can be a result of AWS policy or AWS APIs sort of reorganizing the policies within your definition. Maybe it's a different order on the AWS API side, but Terraform again is reconciling that and saying, hey, by the way, Terraform detected that these changes were made outside of Terraform, and we're going to put them back to the way your definition has them listed. So this is sort of an example of, let's say somebody, again, had access to the environment and they went and modified something. This is what's enforcing our policy to say, no, this is what's in my definition. Please put it back to the way I had it. So that's sort of just like a quick rundown on what this looks like in practice, and sort of the power of demonstrating what that looks like to have a centralized source of known good code, and abstracting away some of that complexity, those 10 different resources that a development team doesn't necessarily need to concern themselves with. They just know that it will work. Because that, again, those sort of guardrails that the platform team set up were there to empower them to be able to do this on their own. So going back to our presentation here, the next sort of maturity that comes with all of those other things set in place is starting to get more and more into self-service provisioning. So this is, integrating your cloud platform, your infrastructure as code, your other automation workflows, and integrating them into the rest of your enterprise tools. So that might mean automatically providing identity into these environments based on a request. It might be a team just sort of filling out a form, and they get all of their environments stood up for them outside of them needing to even write any of the Terraform. And really it's there to empower like users and even like business, like product development, like individuals to be able to adopt, onboarding for their project or whatever into the cloud when they need it. So the self-service piece of this is taking even a developer writing that infrastructure as code using our modules and saying, let's abstract that even further and say, go fill in this form that says, like, here's the name of my team. I want a dev environment and a prod environment. These are the technologies that I'm using on the back end. And oh, by the way, I'm going to need access to this via a jump box or something. So with 4 or 5 text fields, we can submit a ticket to some sort of system, whether that's ServiceNow or some of the developer platforms that are coming out with things like Backstage. We're basically able to ask a handful of questions, and then as a platform team, take that information and go generate the rest of that code on their behalf, and have them come out the other side with cloud resources that are up and running, up to our standards in terms of compliance and security, and they're out there ready to go from maybe 15 minutes of work. So once that ticket gets approved, all of a sudden out the backside, you have your cloud resources provisioned for you without even needing to know anything about the cloud provider that you're pushing to. So this really helps even further with the governance and control policy, because now rather than an individual developer overriding different fields or configuration values in the infrastructure as code, this is a centralized, standardized way of deploying an entire environment or an entire resource of saying, like, I need a new Kubernetes cluster, and here's what the namespace is that I want to run in. We're able to define all of those things via the automation without a developer going in and changing the values and somehow overriding maybe a built-in policy or something. The other piece of this that's really powerful is by getting to the point of self-service, that cost optimization and enforcing who owns what resources becomes a lot easier, because we can now hard code things like who was the requester, who should own this infrastructure once it gets deployed, who do we need to talk to if it needs to be scaled, that sort of thing. So using self-service, we can make sure that different tags are populated. We have tracking around who requested and what's running. If application A is consuming $20,000 of resources in the cloud every month, and application B is maybe using a handful of storage buckets for a couple $100 a month, we don't necessarily want to, at scale, just budget that out from the whole organization. When you're talking enterprise scale and you're divided up into different delivery teams and things, often you will get to a point where you implement some sort of chargeback system to track this cost and say, this is going to come out of your team's cloud budget, to say, this is how much you're using. Here's how we know. Here's our tagging. Here's your bill internally, essentially. And that's sort of another maturity step around of getting this to this point when you start to adopt the cloud. So this is a little bit further down the road, but I kind of wanted to just, this is, when we're talking enterprise scale platform, this is a piece that we need to have in our toolkit, and is a key component to really making this scale. So I'll sort of touch on this as sort of a final thought of talking through this maturity model. I did take this from HashiCorp, their cloud operating model, at least the wording here of, it used to be sort of called like a crawl, walk, run approach, but I really like this new language that we're using around maturity in the cloud space. So just to quickly summarize these three, adopting the cloud, adopting cloud resources. This is a stage in which, it's very ad hoc. We're allowing development teams to go experiment and start deploying resources, start running workloads in the cloud. But it's sort of from a standpoint of, yeah, if you want to go like play around and figure it out, that sounds fine. But what this always leads to is, different implementations with different teams using maybe even different cloud providers, but they're using different tooling, different processes. They may or may not be using infrastructure as code. This is a standpoint where you might just be, clicking around in the console and launching some things, some hosted services, and sort of playing around with it. But almost always this stage results in cost overruns, definitely security vulnerabilities become a huge issue. There's really like inconsistency around what is compliant, what are the standards, and then you're really duplicating a lot of effort of getting to these resources because there is no standardization of how we deploy certain resources. So that's sort of the first stage of cloud adoption. If you don't sort of follow, building out that CCOE, starting to plan and make a roadmap and defining tools and building out a platform stage or platform engineering practice within the organization. This is sort of that first step into like just experimenting what is the cloud. So that quickly identifies a need for this middle stage of standardizing. Once you've got your toes wet, so to speak, there's really a drive to start standardizing how we're going to approach the cloud. This is defining all of the systems, patterns, workflows, tooling, building out that centralized platform with your guardrails in place that can create sort of a shared service model of this platform is going to provide you with automatic logging, compliance, security standards. We're going to deliver something to you where we're abstracting away how you have to build your own networks. We're going to standardize naming and tagging, using infrastructure as code, using automated workflows, and really being able to lock down what we're doing within an environment. And then sort of the final step is that scaling. So this is really more where that like self-service idea comes in of like you get to the point where you can just sort of fill in a form and you've got, resources coming out the other side. This is when we start talking, hybrid or multi-cloud. Maybe you now have a mesh network between your on-premise and AWS and Azure, and you're able to communicate across them in a zero trust way. You're probably organization-wide starting to develop more cloud native services and processes. You're building out on top of that platform that you've sort of standardized on in this middle stage, and you are accelerating that development and that onboarding and ramping up, and you're now at a point where this platform has matured and a new team spins up, and there's no more questions about where it runs or who owns it or any of those things. It's just become part of the organization of saying like, yep, you go make this request to the platform team, and hopefully in a matter of minutes, once that's deployed or once that's approved, you have your environments and things coming out the other side. So this is like sort of the end goal of having a mature platform, is being able to scale this across an entire enterprise and knowing that you have all those other pieces in place. So those are my opinions, I guess, and my experience of what we need to build sort of a cloud platform as a whole, and being able to empower large organizations to scale this adoption within their enterprise. We want to try to move away from that ad hoc or even like just a DevOps model and mature this into a centralized platform that empowers the entire organization to take advantage of public cloud. So with that, I will just pause here for any questions that may have come in.
There are no questions that have been asked so far.
Okay. All right. Well, in that case, I would invite you to reach out, continue the conversation. I've put my LinkedIn and my email here. Happy to talk more about any of these concepts, any advice you might want to be, if something triggers that you didn't think of to ask during the webinar today, feel free to reach out to me. And thank you for attending the webinar. Stay tuned. As Michael said, we come back each week with improving talks, and happy to round out the end of our month of June for platform engineering. So have a good rest of the week. Thank you.
Yeah, thank you, Andy, for that presentation, a great presentation. And thanks for all the time you took to put the examples together so we could better understand platform engineering through the examples you provided. Really appreciate that and all the time you spent on this. Next week, Improving consultant Skylar Tweedy will talk about how your organization can gain key insights more easily from transactional or operational data, or to repurpose your data for secondary use, such as feeding an AI model. As always, these improving talks are completely, absolutely, and utterly free. And we really appreciate you all attending this. You are the best part of Improving Talks, and we really appreciate your attendance at all these talks every week. Andy, again, thanks for a great presentation. Hope to see everybody again next week. Until then, have a great rest of the week and a great weekend.